Good evening students, I welcome you all to my online class on numerical analysis. In last class I explained Taylor series method. So today we are going to solve two problems based on Taylor series method. So just look at the first problem. Consider the initial value problem. dy by dx is equal to x minus y square and y0 is equal to 1. Compute y 0.1 correct to 4 decimal places using Taylor series. So here the initial value problem is given. dy by dx is equal to what? X minus y square. The value of y is equal to 1 when x is equal to 0. So from this we have to find out the value of y at x is equal to 0.1 and we have to find out the answer correct to 4 decimal places. Okay, so how will you proceed? First we have to write down the given initial value problem. So what is given here? So here dy by dx is equal to x minus y square. So this dy by dx we can write as y dash. This dash denote the first order derivative with respect to x. So y dash is equal to what? X minus y square. And this is the initial condition. Value of y is equal to 1 when x is equal to 0. So we have to find value of y at x is equal to 0.1. So here x naught means the value of this, say value of y is equal to 1 when x is equal to 0. So this x, that means x naught is equal to 0 and this value is y naught. So here x naught 0 and this y naught is equal to 1. And y dash x already we know from the given equation it is x minus y square. So how to find out the value of h? So h is given by x minus x naught. So you can consider this, the value of x is what? 0.1. So it is 0.1 minus 0, you'll get 0.1. Okay, now so now what you have to do, from this derivative y dash is equal to what? X minus y square. We'll find out the second order, third order, fourth order derivative and so on. So first you see y dash is equal to what? X minus y square. So here you have to remember this dash denote the differentiation with respect to what? With respect to x. So if you differentiate here, what you'll get? You'll get 1. Differentiation of y square, you'll get it is twice y dash. Again you find out the third order derivative. So here you will get 0, 2 constant. Then here you have to apply the product rule. So ultimately you will get minus 2y, y double dash minus y dash square. Then next you find out the, once you get the third order, next you find out the fourth order derivative. So after simplifying this, you will get minus 2y, y triple dash minus 6y dash, y double dash. And this way we can find out the higher order derivative also. Okay, next we have to find out the value of this derivative at what point? At the point x naught and y naught. So what is the value of this y naught dash? Just to see here, so we have to find out the value of y naught dash. So just to see, so y naught dash, what you will get? If you see here, y naught dash is equal to what? X naught minus y naught square. So x naught is equal to what? 0 and y naught is equal to 1. So you'll get minus 1. Next we'll find out y double dash at the point y naught double dash. So this is equal to again at 1 minus 2 y naught, then y naught dash. Just substitute the value of y naught and y naught dash is equal to minus 1. So it will be 2, 1, minus 1, will get 3. So this way you have to find out the value of the derivative at the point x naught and y naught. So once you get this value, next you have to take the help of the Taylor series method. So just to see, by Taylor series method we have yi plus 1 is equal to what? Yi plus h yi dash plus h square by yi double dash and so on. So this way you will get the terms. So here if I consider I is equal to 0, then you will get y1. So here you will get y naught or y0 plus h y naught dash plus h square by factorial to y naught double dash and so on. So now y1 means the value of y at x is equal to x1. x1 means it is 0.1. And y naught you know the value, h you know the value, y naught dash you know the value. Substitute these values. And here we have considered Taylor series up to 4th order. We can consider 5th and higher order also, but as you move forward, the value of the terms will decreases and there will be very small effect for the higher terms. So we have neglect the terms from h to the power 5 onwards, because here see h is equal to 0.1. So if you take to the power 5, then you will get 0.00000 then 1. So those values are very smaller values when you multiply with the other value. So here I have considered Taylor series of order 4. So if you substitute and simplify, the value of y at x is equal to 0.1, you will get 0.91381. But we are asked to find out the answer correct to 4 decimal places. So if you take 4 decimal places, this is 1, so no need to add 1. So ultimately you will get the value of y at x is equal to 0.1 is equal to 0.9138. So this way we can solve the differential equation by using Taylor series method, and we can find out the value of y at x is equal to 0.1. Okay, now let me explain another problem similar to this. See the next problem. See, find y. We have to find out the value of y at x is equal to 0.1 and x is equal to 0.2. Correct to 3 decimal places. And here the given differential equation, you see, y dash is equal to 2y plus 3 to the power x. And the initial condition y0 is equal to 0. That means the value of y is equal to 0 when x is equal to 0. So now in this case we have to find out the value of y at 2 points. First we have to find out the value of y at x is equal to 0.1 from this differential equation with the help of this initial condition. Next we have to find out the value of y at x is equal to 0.2. So we have to start in the same way what we have done in the previous problem. So see here, first you have to write down the given differential equation. So see the given differential equation. It is y dash is equal to 2y plus 3 to the power x and y0 is equal to 0. That means the value of y is equal to 0 when x is equal to 0, and we have to find out the value of y at 0.1 and at 0.2. So what is the value of x naught? X naught is equal to 0, y naught is equal to 0. H, first we will find out this value. So h we can consider as x1 minus x naught. So x1 is, you can consider 0.1, this point. So it will be 0.1. So same way, say y dash is given. So from this you find out y double dash, y triple dash, and y. That means we have to find out the first order derivative is given, second, third, fourth, and so on. The next we have to find out the value of this derivative at the point x naught and y naught. So this we can denote this way. See, y naught dash is equal to 2y naught plus 3 to the power x naught is equal to 0. So here you will get after putting the values you will get e to the power 0 only. So if you simplify this one, you will get 3. Same way you simplify this, you will get 9. Third one you will get 21. Fourth one you will get 45. Okay, now substitute this value in the Taylor series. Substitute these values in the Taylor series method. You know the expression, this expression. Just substitute the value, and here I is equal to, if you take I is equal to 0, you will get y1. So you will get y naught. So in this expression you substitute the value. So once you simplify, and here also we have considered Taylor series up to 4th order. You can 5th order, from 5th order onwards you will get the values very, very small. So that one we have neglected, because here in numerical method our intention is to find out the approximate solution, not the exact solution. So here we have neglected the terms having h to the power 5 and higher powers. So here after simplifying we will get 0.3486. So hence the value of y at the point 0.1 is equal to 0.349. So here we have to find out the answer correct to 3 decimal places. So in that case, when you simplify, you can find out the digits after decimal, 4 digits, then you do the approximation. Okay, now see the second part. Now we have to find out the value of y at x is equal to 0.2. So we have find out the value at x is equal to 0.1. So with the help of that, we can find out the value of y at x is equal to 0.2. So now you take x1 is equal to, say x1 is equal to 0.1 and y1 already we have find out the value. Y1 is equal to 0.349. So from this you find out the derivative at this point x1 and y1. So once you find out these values, see here, just you just put the values and simplify, you will get the values of these derivatives at this point x1 and y1. So once you get these values, then you take the help of the Taylor series method. Here you take I is equal to 1. So if I take I is equal to 1, you will get y2, and here y1, and h y1 dash h square by factorial to y1 double dash. So this way you will get the terms. Okay, y2 means the value of y at x is equal to 0.2. So now substitute the value and simplify. Once you simplify, as because you have to find out the answer correct to 3 decimal places, so I have taken the 4 decimal places. After that you can do the approximation. So here, as because it is 6, so if you take after answer 3 digits, then you have to add 1 to this number, so you will get 0.812. So this way we can apply the Taylor series method to find out the solution of initial value problem. Hope it is understandable. In next class, we'll do another method, Euler's method for solving first order differential equation. Hope it is understandable. Thank you.